a lot of products that seem to be designed by someone who apparently has never used a product of that kind before. Maybe you've had that same sort of experience. I run into software applications, websites, and physical products like cars and household items all the time that just make me wonder what the designer was thinking. Sometimes we might have problems trying to figure out how to use a product, and that can make us feel dumb, but usually it's not our fault. Much of the time, a product is hard to use because it's not thoughtfully designed. So I wrote this book, The Thoughtless Design of Everyday Things, to share some of these experiences and see what we can learn from them about doing better product design. I'm going to begin today with a definition of what I mean by thoughtless design. And I'm going to describe 3 reasons why I think design is a pretty hard problem. As I was writing this book, I looked at a lot of examples from different people and my own experiences, and I identified 9 fundamental principles that I think are important about good design. The book contains more than 160 examples of products that don't conform to those design principles, along with suggestions for improving many of their designs. Today, I'll show you quite a few examples of those thoughtlessly designed products. But I also describe almost 50 examples of what I think are particularly well-designed products in the book, and I'll show you some of those today too. But you know, I'm sure you've had this experience where you use some product or some piece of software or a website or a phone or something, and you say, wow, that was really nicely designed. And we're surprised by that, but we shouldn't be surprised. I don't think that should be a pleasant surprise when you encounter a well-designed product. I think it should be the norm. So along the way, as we continue here, I'm going to show you 19 of the 70 design lessons that I extracted from studying these various products. I think if we keep those lessons in mind, we can not only do a better job on design ourselves, but as consumers, we can do a better job of defining our requirements when we go to buy something, instead of getting it home and saying, oh, that's not what I wanted. That's stupid. I should have thought about this more carefully before I bought it. Finally, I'll wrap up by summarizing some good practices for usage-centered design, which I think is the best approach to building usable products. Let me give you an example of what I'm talking about here. I have a nice blue jacket that looks kind of like this one, that is well designed overall. It's comfortable, it's warm, I like it a lot, but it has one peculiarly thoughtless feature. There's an inside pocket that's about 5 inches wide. And that's a nice size for holding a phone or a museum brochure or sunglasses, something like that. But for some reason, the jacket designer sewed a big seam down the middle of that pocket, thereby splitting it into 2 much smaller and less useful pockets. And I just do not understand why someone would do that. What customer said, this 5-inch pocket is way too big. Why don't you make 2 small pockets instead? I suspect no one said that. And so it's a continuing annoyance to me in what is otherwise a nicely designed product. So when I talk about something that's thoughtlessly designed, I'm thinking of products that violate 1 or more of my 9 design principles. And the sad thing is that many of these products could have been designed better with just a little bit of additional effort, not a lot, just some more careful thinking, maybe some better consumer engagement. Let me define some terms I'll be using here. A product or a feature is obvious if its presence and usage are readily apparent without anyone having to explain it to you. You just see what it can do and how to do it. A product is intuitive if you can make a good guess at how to use it based on its similarity to other products or from other cultural or contextual cues. You don't need to consciously think about how to use it or refer to a manual, you just use it. A product or a feature is easy to use if the user can successfully perform a task with minimal effort and assistance. All right, so if we think about the products we've encountered, we should ask ourselves, why aren't all products thoughtfully designed? And I don't mean to suggest that product design is easy. It's not. There are 3 major reasons, I think, why design is hard. And the first one is requirements. Our first problem arises because designs are based on requirements, and we, of all people, know how many problems people encounter when you're trying to develop an understanding of requirements for any product. And here's a picture of a very early business analyst writing one of the very first requirement specifications. Okay, I lied. It's really Charles Dickens, but it could be a BA, who knows? So here are some of the reasons why problems with the requirements could lead designers in the wrong direction. They're often incomplete, or maybe not very accurate, or the information that you're reporting is obsolete, out of date. Sometimes we don't talk to the right people or can't talk to the right people, and so our requirements come from the wrong people. Too often, and this is something I heard over and over, and I'm sure you've encountered it as well. I've been a consultant for more than 25 years, and the single biggest complaint I've heard from my clients talking about business analysis is that our customers don't give us requirements, they give us solutions. And so if we're focusing on solutions and not on needs, there's a good chance we're not going to get the requirements quite right. I think another serious problem is that too often people focus on features and functionality instead of starting by reaching an understanding of how people are going to use the product. So I'm really sold on a usage-centric approach to understanding requirements. Very naturally, people focus on functionality, the things that a piece of software or a product, a physical product, would let you do, or the things you can do with it. But if you're not careful, you can overlook very important non-functional requirements, often called quality attributes, which then make it harder to build a product that people find fully satisfactory. And even if you got all these other things right and got the right information, it could have been poorly recorded or poorly communicated to all the people who need to know. So we have to write things in a way that's clear to the audiences for those information. So that's a common problem, requirements as a foundation for design. That's one reason why design is hard. There's another reason. It's important to remember that perfect design solutions are unattainable. Any solution is always a compromise. Designers need to try to please a lot of stakeholders who can have conflicting interests and objectives. I've shown just a handful of the kinds of stakeholders that you might have to deal with here. And you can see that they're going to have some competing tensions. You'll have with this source of tension in the design process trying to satisfy the complete set of requirements and constraints that these various stakeholders present. So for instance, certain product characteristics might make it easier to install or to service some product, but maybe those same characteristics aren't very convenient for users. Or the manufacturer might like a design that's easy and cheap to produce, but customers aren't going to be very happy if that makes the product less durable. At the bottom here, I've shown multiple user classes. Most products don't have a type of user. And so I always get nervous when I hear people talking about the user. They have multiple user classes who have different characteristics, needs, and expectations. So the problem here is that it's very hard to make all of your stakeholders ecstatic with any given design. A third reason why design is hard is because a product exhibits many different quality characteristics. These are sometimes called design for attributes. In software, we usually call them quality attributes. Here's a list of some of the familiar design for attributes for software systems shown on the left, and you're all familiar with those, with a supplementary list for physical devices shown on the right, because those physical devices often contain embedded software, and then we have to worry about the attributes from both of these columns. Basically, it's impossible to build a product that maximizes all of the desirable attributes. Also, some of these attributes conflict with each other. Increasing one can decrease another. If you increase security through, for example, multi-factor authentication of the user, that decreases usability. Sometimes you even need to use multiple devices to get into an application so you can do what you want to do. And that certainly hampers usability. So there are trade-offs. Designers need to know which of these quality attributes are most important to business success for the product, so they can make the right design choices to achieve the best balance. That's why an exploration of these quality attributes is an important part of requirements development. So design's hard. Let's see what happens as a result of the designs that we end up with being inflicted on us. As I mentioned, the book presents 70 design lessons that I derived from observing both poorly and well-designed products. And these weren't just from my own experience. As I was writing this book, I had a lot of reviewers and talked to a lot of people and got many examples from their own experience of products they hated, and occasionally an example of something they really liked. So I've got a real cross-section of different kinds of things here that we can learn from. Here are the first 3 lessons, which I think are the most important. I've already alluded to this, and we'll come back to it again. Let's focus our design on usage, not on product features. Usage-centric design means understanding how people will use the product. Think about what people want to do with the product and the environment in which they'll be using it. Then design the product to make it easy for users to get the job done. Second, design demands iteration. I'm not sure what your experience is, but I've never been able to get a design right or optimal on the first try. You have to plan to iterate, approaching a better design with each cycle until you have a design that's good enough to satisfy the requirements. Well, if you're iterating on your design, how do you know what to change in the next cycle? Let's involve real users. Ideally, typical user representatives will work with a prototype or a mock-up under realistic usage conditions. Users will give you insights that you just can't get in the design lab or from talking to other people on your design team or your development team. Sometimes we can't really involve real users. You have to work with user surrogates, but there is no substitute for having real users participate in the design process. So now let's take a look at my 9 design principles and see some product examples and some more design lessons from each of those principles. The first design principle should hardly require stating, make the product easy and obvious to use. And here's an example of kind of what brought this home to me. A couple of years ago, I rented a small SUV at an airport. I don't have much experience with SUVs. Mostly I've driven sedans, and I've driven a whole lot of rental cars. So here's a picture of the back of that car. And I could not, for the life of me, figure out how to open the tailgate on this vehicle to put my suitcase in. I spent about 10 minutes in the dark garage at the airport, groping around for a latch, a handle, a button, a keyhole, anything that might give me a clue as to how to open that back hatch. I couldn't find it. There was no button on the key fob, as there usually is. You know, I'm used to having a button on the remote where I can unlock the trunk if I want to. I couldn't find a button or lever anywhere inside the car to open the tailgate. I finally had to ask the rental car people for assistance. Now, it turns out that the red oval there on the right shows the door opening handle, which is above the right tail light. Now, that looks very much like the non-functional chrome piece above the left tail light. Is this obvious to you? It sure wasn't obvious to me. And I didn't feel so bad when I talked to a friend of mine, a very smart guy, another traveling consultant, and he told me he had rented that exact same model of car and had the exact same problem that I did. His was worse. I was at least in a garage with employees nearby from the rental company that I could get some help. He had walked to the car in the parking lot, had to walk back in the pouring rain 100 yards to the little rental booth, and then walk back to the car again once they told him how you open the back. Now that's just stupid. That is the epitome of thoughtless design. And the lesson here that I gleaned is that small design problems can interact to yield unexpectedly significant results. You have a disguised handle, you have no opener inside the car, no button on the key fob. Each of those was a small design choice, but when you put them all together, it made it impossible for me to open the tailgate, despite my having used dozens of rental cars in my long career. It was not obvious, it was not intuitive. Now, it wouldn't have been much harder to provide the multiple alternative opening mechanisms that most people are used to. And this is the kind of problem that should be discoverable during a prototype evaluation by real users who haven't seen the car before. You mock up your cool design ideas, and then you get some real users, which could just be other people you know who happen to drive cars, and say, can you open the tailgate? And see how long it takes them. See how many tries it takes. See how many errors they make. And that can give you a clue as to whether your design is a good design or a thoughtless design. Here's another example of an unobvious design. I have a lot of examples in the book from iPhones. I could probably get just as many from Androids, but I'm only familiar with the iPhone. I also have some very good examples. I think there's some very, very clever, thoughtful design in an iPhone, but here's one that's I thought a little silly. This is the timer feature on my iPhone. Some of you have no doubt seen this. The image here on the left shows how the timer looks when it's counting down, in this case from 5 seconds. Now the image on the right shows what the screen looks like after the timer countdown has reached 0. All right, so here's how I learned about this example. A very smart friend of mine with almost 50 years of software development experience used this timer when a bunch of us were playing a game one night. He set the timer for 30 seconds and the alarm sounded just as it should. However, it took him 30 more seconds with help from all of us trying to figure out how to turn the alarm off. It's totally unobvious. Now, some of you may have figured this out, but we tried several things. There's a cancel button. Oh, let's try that. It doesn't do anything. Now, I don't know why it's even showing me an option that has no function whatsoever. Now, you could say, well, it's grayed out. Well, it was gray to start with. Cancel is on gray on the left. It's just a darker gray on the right. Why show me something that doesn't do anything? I don't get it. Oh, wait, okay, I tried the start button. Well, that just restarted the timer. The alarm was still sounding. It starts the timer again, and then the alarm goes off when the second timer reaches 0. That's insanely stupid. That makes no sense to me at all. Now, it turns out there are a couple of ways you can turn it off. You can hit the home button on the phone, not obvious. You can tap the timer, the little gray bar at the top that says timer. Now, that's not obvious to me that tapping that will turn off the alarm, but it does. And there's a little horizontal bar that is actually a clue that you can pull it down, and then you get as an explicitly stated option to turn off the alarm. But that is totally unobvious. We found it completely comical. So a lesson from this app was that it's a bad idea to provide the user with options like this cancel button that don't do anything, or suggest that they'll do something different from what they actually do. Software systems should present the user only with unambiguous and useful options. So we finally figured it out, but I don't think it's a very good idea to do things like this, that the user has to work that hard in a basic app to discern. I would have felt a little different had none of us seen a phone before, none of us had used a computer, but of the people who were playing these games, I would say we probably had, I'm just trying to do a little math here. We probably had between us about 220 years of software experience, and we could not figure it out. I think that's a problem. All right, I encountered some surprising behavior in Microsoft Excel. I had made some changes in a workbook that was still open, which caused the undo function to become active. Okay, when I then created a new workbook, I noticed that the undo shortcut button was still active, as you can see inside the red circle here. Okay, so I've got in the toolbar the undo, and that's alive. But I hadn't done anything yet in that second workbook. There was nothing there to undo. That puzzled me. So naturally, being a computer person, I had to see what happens. So I clicked on the undo button, and here's what happened. Excel reversed my most recent operation from the first workbook. The view switched back to that first workbook after it did the undo, so I couldn't tell what had happened. You couldn't see anything change. I found that very confusing. This is not how undo works in PowerPoint and Word. And we expect that members of a product family like those in Microsoft Office will show common behaviors from the same functions. For the most part, they do, but they don't always. So the first lesson here is to make sure that the user won't be surprised by unexpected and undesired behavior. And I would say undoing something that you didn't request to undo is unexpected and undesired. There's a second lesson as well. Use context to activate relevant functions. There's no point in having undo be active if there's nothing to be undone in the present context. All right, so moving on to my next design principle, consider realistic usage scenarios. I mean, here's an interesting example. couple of years ago, I had to buy a new wall oven. My previous wall oven in my house had a literal meltdown, which was quite exciting when it happened, and I needed a new oven. So I like this one that we picked out, okay, but it has one absurd feature. Here's the control panel for the oven, as you probably figured. And one thing you want to do with an oven is use a timer. The oven does have a timer that sounds an alarm when it counts down to 0. Great. But that alarm is way too quiet. If you're more than a few feet away, you're unlikely to hear it over normal household background noise. And here's a thoughtfulness scale that describes how this oven's alarm feature was designed. The nominal behavior is that the oven does generate sound effects under appropriate conditions. Yeah, we like that. It should be there. And here's a thoughtful aspect. The designers allow the user to set the volume to one of 3 levels. That's considerate. However, the highest volume setting is still so quiet as to fit into the thoughtless design category. And the lowest volume setting is just comical. So this should be our design scale for assessing how thoughtful or thoughtless a design is. You have to stand right next to the oven to hear the alarm on that lowest setting. And that kind of defeats the whole purpose of having an alarm. I could just look at the timer on it and see what's going on. Now, maybe this oven was not adequately tested in realistic home usage scenarios. My previous oven had a loud buzzer that I could hear pretty much anywhere in the house. This one sounds like the gentle tinkle of a distant ice cream truck. And sometimes the sound barely penetrates my consciousness. It's pretty frustrating. Perhaps you've seen something like this. Oops, sorry. Okay, there we go. It seems obvious that products should be designed so people can use them effectively in a wide range of normal, realistic usage contexts. But sadly, that's not always the case. I'd be interested to find out if any of you have seen something like this. Have you ever seen silverware at a restaurant or a cafeteria that has smooth cylindrical handles like these? It's impossible to get a secure grip on them. The knife rolls in your hand if you try to cut a piece of meat or butter some bread. Eating cereal or soup with the spoon requires careful attention to make sure it doesn't spin and spill food in your lap. I just cannot imagine why someone would design such an everyday product in a way that simply doesn't work well in an ordinary usage context, that is, eating. Our hands grip flattened and textured pieces of metal far more securely than these smooth round ones. This is the kind of design that just makes no sense to me at all, but they are available in multiple colors too. So I guess they're there for somebody. I just don't know who. I do have many examples in the book of iPhone designs, as I mentioned, and some of them are great. Others are ridiculous. But the Contacts app illustrates some thoughtful design. For instance, the input controls change depending on which field you're entering content into. In the email field here, the alphabetic keyboard pops up, and that makes sense. But I don't really understand why they included the emoticons and spacebar, as you don't normally find those in an email address. But my guess is that they're reusing a standard keyboard control here. And that's interesting because while software reuse is a very good idea, sometimes there are compromises. Sometimes the thing you're reusing isn't a perfect fit for the reused environment, and you have a trade-off here. But I've never tried putting an emoticon into an email address. Who knows, maybe it's interpreted somehow. Now, if you're entering content into a date field, Apple pops up this rotary date entry control. And I didn't show an example here, but if you're entering a phone number, the numeric keyboard appears with all the special characters you might need. So that's pretty thoughtful. And I think this is a thoughtful design because it is using context to activate appropriate controls, which saves the user time and reduces user errors. You can't put an invalid month in the date field if you can only choose from the 12 months of the year in the control they provide. I've seen controls in other applications that let users enter invalid dates like February 30th. That's not too good because then you have to write code to validate the input. It's better to avoid making mistakes than to have to clean up afterward. It's also important to consider a wide range of usage environments. I have quite a few examples from cars, but that's because I've driven a lot of different cars, and sometimes they're great and sometimes it's like, no one ever drove this car before. And here's an example. I rented a car in January a few years ago in Boise, Idaho, fairly chilly. And here's a photo of the climate control system. Now, I've rented this particular model quite a few times before, and generally I like them pretty well. This has clearly labeled buttons and a reasonable layout. However, I found something interesting. I kept hitting multiple buttons when I tried to adjust these controls with gloves on. It was January, remember? The buttons, some of them at least, were too small and too close together. For instance, if I press the rear defroster button here inside the oval, this is the button on the right, I would find that the seat started getting warm. That's because I also had inadvertently turned on the seat heater, which is the button immediately to the left of that. It was too hard to miss that, and it'd be confusing then when I'm getting responses like this that aren't what I expected. So when you're manipulating the controls of an unfamiliar car while you're driving, maybe at night, that's hard enough. But when you get an unexpected outcome, it's annoying to have to figure out what's going on. So a lesson from this is to ensure that the design is usable and safe in a wide variety of likely operating environments and conditions. And when I drove this car, it made me wonder if the person who designed this climate control panel had somebody test the design while wearing gloves. I kind of doubt it, but that's a reasonable thing to do. In fact, you're more likely to need the heating functions here when you're wearing gloves than when you're wearing shorts in the summer. Now, if you're building a system that contains software and is supposed to be used in a variety of environments, here are some factors to consider. Check to see how well it works under different lighting and weather conditions. I've seen ATMs, for example, whose screens were nearly impossible to read at times because of screen glare from the sun. If the product involves audible input or output, like speech recognition or synthesized speech from a kiosk or a supermarket self-checkout device, make sure the sound levels are appropriate for the intended operating environment. They're loud enough for the user to hear, but not so loud as to disturb or distract others nearby. Well, my fourth design principle is to make it hard to make a mistake. These controls are from my brother's pickup truck. The knob on the right controls the headlights. There's an identical knob a couple of inches to the left, or I'm sorry, the one on the left controls the headlights. The identical knob on the right controls four-wheel drive. My brother's a mechanical engineer and has driven trucks for a long time, and he says that it's easy for him to grab the wrong knob, which could lead to some startling results. You're trying to turn on your headlights and you find yourself switching into four-wheel drive. That could be a little startling. Symmetry like this is nice for visual design, but it's not so good for usability, especially by touch. There are four ways a designer can consider how to deal with user mistakes. The best option, let's make it impossible for the user to make a mistake. That's like the example of having the date control that means you cannot enter an invalid date. That's the best way to do it. But that's not always feasible, so a good alternative is to make it difficult for the user to make a mistake. Maybe the designer here could have made the knobs different enough that a driver could tell by feel if they'd grabbed the correct knob. A third option is to make it as easy as possible for the user to recover from an error, either one of their own making or some system error that takes place. The worst option is to don't think about it at all. Just let the mistake happen and force the user to deal with it. So the principle is that we want to make products easy to use correctly, but hard to use incorrectly. Let's see a few more examples. We want to make it very hard for a user to take a destructive action by mistake. I think that's a really good design approach. And that means making the options clear so the user isn't surprised when they take some action. And I suspect that all of us here have at some point done something with a computer that was not exactly what we had in mind, but they made it too easy for you to do that wrong thing. So here's the screen that I see if I ask to delete a mailbox, which is just an email address, at the control panel for my website. I just love my hosting provider, Tiger Technologies, which I believe is based in Portland here. They're the best technical company, best technical support I've ever dealt with. They don't have a fancy, sexy website, but they have a very functional, clear website. So the hosting provider here makes it perfectly clear what will happen if I choose this option. Okay, I have to take another step. I have to tick this checkbox to confirm that I want to make the deletion, and only then does the grayed out button at the bottom to delete the act, to take the delete action, only then does that become active. Even better, after I delete the mailbox, I get another message that says, if you did this by mistake, I can recreate the address right on that same page, and the deleted email will automatically be restored to it. Even better than that, the hosting provider gives me a month to correct a mailbox that I deleted by mistake and restore all the mail. I think that is a very considerate, thoughtful design. It's just one of the many reasons why I always recommend Tiger Technologies to people who need a hosting provider. So here are some tips, so some suggestions about how to design products to help users avoid making mistakes in these 4 categories. We'd like to make mistakes impossible. One way to do that with physical products is to use asymmetry to make sure the pieces fit together properly. For example, there's only one way to connect a USB cable to a USB port, but unfortunately, you have to see both ends of them to be able to connect them properly. And that's a big disadvantage, because a lot of times the other end is around the back and the bottom of your computer under your desk or someplace like that. So another solution is to actually use symmetry. The USB-C and Apple Lightning plugs are symmetrical, so you can't get it wrong. That's really the perfect solution. For software, don't offer the user options that are illogical. That makes it impossible for them to make certain mistakes. For example, the ATM at my former bank always would ask me which account I wanted to use when I said I'd like to do a deposit or a withdrawal. It gave me 4 choices: primary or secondary, checking, or savings. Guess how many accounts I had at the bank? That's right, 1. So it's giving me 3 incorrect and 1 correct option, and I have to choose the right one. That's just dumb. I mean, there's no reason to do that and then put in all the code to figure out, well, can we do what the user requested? Let's just give them the choices that make sense. Software can prevent mistakes by constraining or correcting or reformatting user input instead of reporting an error and making the user fix it. Have you ever entered a phone number someplace and it complained because, oh, you're supposed to use hyphens, not parentheses or dots or something? Or you enter a date and it doesn't like it because, oh, you didn't say 2000 in front or 21 in front or anything else. It's, you know, it's making you do it in a way that it wants, even though it's capable of reformatting things. Now, if an error happens anyway, the product should help the user correct it. Don't think of a problem report as being just an error message. Think of it as a guide to recovery. I'm not going to give you any tips if you're just going to force the user to deal with whatever happens. You don't need any help from me if that's the choice you make. Another principle I think is important is to provide meaningful feedback. I'm sure you've seen messages from computers that are just as useful as the one this guy is holding. And those messages always make me wonder, why are you telling me this? What am I supposed to do with that information? I don't understand. There are 7 characteristics that I think meaningful error messages and other system feedback should exhibit. It should be immediate. We'll come back to that in a moment, I think. It should be informative. Tell me something I don't know and need to know. The feedback should be necessary. One website I use sometimes shows me that I have a notification when I log on. Okay, so I dutifully click on the icon to access my notifications. And all it says is, you have no notifications. That's an example of completely unnecessary and time-wasting feedback. The feedback needs to be clear. I need to understand the point of the message. Otherwise, why bother showing it to me? It should be actionable. Show me what I need to do next as a result. Don't you hate messages that flash by long enough for you to see that there was a message, but not long enough to read it and process it? Someone else decided how fast you read and think. Messages that aren't persistent are annoying. Finally, I think messages should be polite. I'll show you an example of a nicely polite message in a moment. But first, let's see some more feedback examples here. Consider this idea that we should make the feedback clear. I wanted to cancel a magazine subscription. And here's the kind of dialog box I saw when I submitted my request. Are you sure you want to cancel your subscription to this magazine? And I got the 30-year-old default button choices, okay, and cancel. Well, this message is ambiguous. If I click on cancel, will that actually cancel my subscription like I'm requesting? Or will it cancel out of this dialog? That's not clear. And a way to fix that is to label the buttons clearly and answer the dialog's question, rather than using things that are potentially vague like okay and cancel. Give the buttons meaningful labels that logically answer the question in the dialog box. This way the user knows exactly what will happen if they click on each button. Also, the buttons don't have to look alike. You can design buttons that make it harder for the user to hit one by mistake that would be more destructive. Maybe a bigger green button for the safe option, a smaller red button for the riskier option. Anything we can do to make it just a little bit easier for people to get the right thing done and not the wrong thing. That's good design. The feedback you provide to a user should let them know what to do next. Here's a good and a bad example. Here's the error message I often see after I make a backup from my PC to an external hard drive and then try to eject the drive. Problem: Windows can't stop your blah, blah, blah device because a program is still using it. Close any programs that might be using the device and then try again later. All right, this is annoying because Windows clearly knows what programs are currently using the drive, but it doesn't tell me what they are, and it doesn't give me any way to turn them off. All I can do is close this message box and try to figure it out on my own. And for example, the backup software I use, I actually have to close it 3 times. I have to exit the application. I have to then go in Windows to the system tray and shut down the little thing that's lurking back there, keeping it alive. And I have to go into another function and kill the process manually. That all prevents that drive from being ejectable. That's just stupid. No normal person is going to figure that out. Now contrast this kind of message with a much more helpful message I get, again in Windows, if I try to delete or rename or move a file that's open in an application. This action can't be completed because the file's open in Word. Close the file and try again. Great. It's a nicely actionable message that tells me exactly what's going on and gives me some clues about what to do about it. So again, don't think of this as kind of feedback as error messages. Think of it as guidance to help the user solve a problem. And here's, I think, a good example of thoughtful design. I use Mozilla Thunderbird for email. Thunderbird looks for keywords in your text that suggest you might have an attachment for the email you're sending. It looks for attached, attaching, enclosed, .pdf, and you can actually customize that list. Very thoughtful. If it doesn't find an attachment, then when you attempt to send the email, you'll see a friendly reminder politely inquiring whether you meant to add an attachment. Notice how the buttons are labeled in a way that answers the question. Did you forget to add an attachment? Yes or no? Okay, that's better than okay, cancel. What would okay, cancel mean there? I have no idea. So this way I know exactly what will result from each action. So I think this message hits all 7 of the desirable characteristics of feedback to a user. Wouldn't it be nice if all the messages we saw from computer systems and hardware devices were like that? I think that it would help make them easier to use. Let's not waste the user's time. Here's an example. This is the home page for a financial services website that I use. This page is 100% content free. I don't know who that guy is or why I'm looking at him. The login fields are below the fold. I have to scroll down to access them, or else I can click on that tiny logon button that I've circled in red at the top right. Making me take extra actions like that wastes my time. Now, maybe the company did some usability research and they found that the majority of visitors who land on this page want to look at that guy with his cup of coffee and click on their promotional link, but I doubt it. I bet most people who see this page want to log into their account or look something up as efficiently as possible. Some other time wasters like this include this currently fashionable website design with huge fonts, meaningless stock images, and lots of white space that require the user to scroll, scroll, scroll to get to anything you're interested in. I find that very irritating. Sometimes I waste time trying to find the logout button on a website or a phone app. Cleverly concealed options like that suggest that the site owner doesn't really want you to log out, but that's my choice. It should be easy to find the logout button. So the lesson here is to let the user take the fewest possible actions to perform a task. In the interest of not wasting the user's time, the designer should also make it easy for users to access the tasks they perform most frequently. A good way to decide how to lay out screens is to collect some data on how people use the application. An operational profile is a concept from software reliability engineering, and that defines the percentage of time that users will be performing various tasks in the sessions. So this helps user experience designers set defaults and priorities for screen layouts and menu items to save users time, to make it easy for users to access the tasks they perform most frequently. Here's a nice example. This financial services provider has collected data on the frequency of different kinds of transfers and payments, and they put the one that's used the most frequently at the top, and they even labeled it. And that is indeed the one that I always use. This layout saves me time because I don't have to scroll around through some other list, a bigger list than this, to try to find the one I'm interested in. Now, avoiding 1 or 2 clicks or scrolls, that might not seem like much of a time savings. We'll multiply that times millions of users and many millions of sessions, and it's a lot of clicks and a lot of time saved. Too many application designers seem to view their customers' time as being free. It is not. Well, one morning I went shopping at 2 supermarkets. The cashier, the first one, was friendly and efficient. Before I knew it, my bags were full and the receipt was in my hand. The cashier at the other store, though, kept giving me instructions. I had to do things in a certain order. The cashier became impatient with me if I took too long pulling out my loyalty card or making payment. I think I forgot to mention that the first cashier was a pleasant young woman, and the cashier at the second store was this machine. I think it's hard to imagine a product less thoughtfully designed for the user's convenience than your typical supermarket self-checkout station. Now, some are better than others. If you're doing something simple that doesn't require anything being weighed, no products without a barcode, no coupons, no alcohol, requiring an age check or anything like that, then they may be okay. Today, in fact, I used one of these machines and it went fine. But otherwise, they're often problematic and annoying. I have been known to actually give up. One time I was trying to buy 3 items and the machine called for help 3 times for 3 items. And so my inclination, I just leave my food there and walk out of the store and go someplace else to get it. That's just too annoying. So the lesson here is that products should be designed to tolerate both technical faults and unexpected, imprecise human behavior, like taking a little longer to pull out your payment card or your loyalty card. So along the line of designing for the user's convenience, here are some other lessons that we should keep in mind. Letting users customize their experience whenever possible is a big help. Customization is a good way to reach a good balance between the ease of learning and ease of use, and to make a product usable by a wide range of customers. For example, my car lets me customize many aspects of its behavior. I like that. Another way to enhance the user's convenience is to let the computer do as much work as possible. Here's an example. Have you ever typed in some long entry, like in a problem report online, only to be told when you try to submit it that it's too long? But you don't know what that maximum length is. You don't know how much you have to take out. You have to just keep guessing. Now, if you have an input field with a character limit, don't make the user guess how many characters they can enter. Tell them how many they can enter and how many they have left, and stop taking input when they reach the limit instead of showing them an error message later. Showing error messages like that gives you non-immediate feedback, and I think immediate feedback is much more useful. Another good way to consider the user's convenience for physical things is to design packaging that customers can open easily and safely. I just don't understand why we have so many packaging failures. I have a lot of examples in the book that just drive me nuts. And I'm sure you've had your own experiences with poorly designed packages. So why is this a problem? Cardboard and plastic are not new technologies. Some people manage to master the art of packaging that's easy to get into. Some companies just don't seem to get it. Now, when it comes to the user's convenience, we have to watch out for deliberately devious design. The word thoughtless can mean either showing a lack of thought, or it can mean inconsiderate of others. So far, we've seen examples of products that showed a lack of thought in their design, but some websites are deliberately inconsiderate of the users, and some are designed to be absolutely fiendish. Here's an example from the website of the bank that issued one of my 2 credit cards. When I go to pay my bill, this payment page doesn't show how much I owe. It only shows the minimum payment due of $25 in 3 places in these red boxes. I need to click on this little e-bills link in the red oval to find out how much I actually owe them this month. This website is clearly designed for the benefit of the business, not of the consumer. And I think that's wrong. They want me to pay just the minimum amount each month so they can charge me millions of dollars of interest. But instead, we should design for the benefit of the consumer over that of the business. There are all kinds of so-called dark patterns like this, ranging from various subtle deceptions to downright fraud. You have to be careful to understand just what will happen when you click on some button. Our 8th principle here is to accommodate the range of human variation. Human characteristics span a very wide range of differences in multiple dimensions, and hence the value of this lesson. While it might not be possible to make every product equally usable by everybody, designers should respect the variations and be as inclusive as possible. Here are 2 examples of thoughtless design that don't account for some of that human variation. 2 of my friends reported the same design problem. One was a man in his late 60s and the other is a woman in her late 70s. They both lived in condos in different retirement communities, but they both reported the exact same problem. The furnace filters in their condos, which of course need to be replaced periodically, are installed at the top of a 12-foot high angled ceiling. Now, the condo designers knew that these were for older people, some perhaps with disabilities, and almost none of them with 12-foot ladders, let alone want to climb up on the ladder. So this is just inconsiderate design. Another friend works for a utility company. She creates maps of access roads so people can service power transformers and the like. The roads are color-coded so the drivers know which ones they can use and which ones they can't. But the people who defined the mapping conventions chose colors that some colorblind drivers can't distinguish. Color blindness is quite common, so any visual display needs to account for the possibilities of users who have color vision variations. Some people have done a nice job of accommodating some of these different human variations. Here are 2 examples. About 10% of the population is left-handed, but a lot of products are much easier for right-handed people to use. These days, a lot of computer mice, that's the one I'm using right now here, are symmetrical. And computer operating systems let the user configure the buttons to be logical for either right or left-handed people. That increases how usable they are through the configuration and customization capabilities, increases their general usability. In our seemingly interminable days of COVID-19, most people are wearing face masks. At least in Oregon, they're very good about that. Not true everywhere, but that's okay. Here, we like it. But face masks pose a communication barrier for people who are hearing impaired and read lips. I should point out that no, I don't like wearing a mask, but I don't like being sick either or dead, so I wear masks. Some companies have designed masks like this one with clear plastic, so you can see the person behind the mask. And this is good not only for people who need to read lips, but it's good for having a better emotional connection with people. For example, in a medical setting, it's a little less scary than people coming at you with half of their faces covered. I think that's clever and considerate design. My final design principle is to place the minimum mental burden on the user. Here's a screen that I see when I ask to log out from one website. Are you sure you want to log out? Any unsaved data will be lost. Whoa, makes me nervous. That's a problem. Now, the system knows if I have left any data unsaved during my session, so it should only warn me about this if I really do have unsaved data. Why put the burden on the user to keep all that straight? The system knows. If I do have some, where is it? And how do I get back to the right screen to fix the problem? This is an example of non-actionable user feedback. I don't know what I'm supposed to do with that information, except maybe get nervous that perhaps I did something wrong. The simple improvement of warning the user only when there really is unsaved data and then helping them to save it would completely solve the problem with this design. Another important lesson is to make functionality that's shared by multiple members of a product family consistent. We saw this earlier with my undo example in Excel. But this enhances both ease of learning and ease of use, and it facilitates software reuse. For example, have you ever noticed how many different ways there are to delete objects on an iPhone? The prompts, the icons, the actions, they're all vary depending on what kind of an item you're deleting. Sometimes you need to confirm the deletion, sometimes you don't. I've seen cases where I had to confirm deletion of a single object, but not confirm deleting a whole group of the same items. Which of those is the more destructive action? Well, getting rid of more is more destructive than getting rid of fewer. So in this case, it seems like the team that built each app decided to implement the delete function however they wanted to. No overarching architectural decisions. But this confuses users and it increases their learning curve and their error rate. Yet another inconsistency shows up in Microsoft Office. We expect a lot of common behavior across Word, PowerPoint, and Excel. There is a lot of common behavior, but there are enough inconsistencies to waste my time when I try to do something that works in, say, one or two applications, but not all of them. Here are a couple of examples with shortcut keys. I use this copy formatting and pasting of formatting all the time. And in Word and PowerPoint, it works one way, and in Excel, it doesn't work. Those key combinations do something completely different, which can be a bit of a surprise. We don't like surprises, remember? All right, I want to wrap up here by saying a few words about some good practices that I think can lead to more thoughtful designs of any product. If you agree with my premise that usage-centered design is superior to product or feature-centered design, then let's begin by understanding our stakeholders. Customers constitute a subset of stakeholders, and user classes are a subset of customers. Remember, just about every product doesn't have a user. It has multiple user classes, all of whose needs the design must address. So during requirements development and design, you need to engage appropriate customer representatives of these various user classes so you understand their needs and can validate solution ideas. I call those user class representatives product champions. And in a model that I found works very well for requirements development, these product champions work with a business analyst or a requirements analyst or a product manager to bridge the gap between customers who have needs and developers who craft solutions. So a few more practices here for thoughtful design. Personas serve as stand-ins for human beings when you don't have a real person available to represent a particular user community. Again, not as good as having the real person, but sometimes an alternative. Prototyping is an excellent way to iteratively understand requirements and evolve designs. A prototype is a partial, preliminary, or possible solution to your problem. It's a lot easier for users to envision what a product might be like and how they would use it if they can interact with a tangible prototype instead of reading a bunch of textual requirements and diagrams. And here's a cycle of steps that you might go through when you're using prototypes to design a product. You develop some initial requirements, typically by a BA working with some customers, which can lead to at least one possible, hopefully multiple possible solutions. From that, we might decide to create one or more prototypes that can then be used to get some feedback from customers who can work with that prototype, which will help us refine both the problem statement and understand our requirements so we can go back and iterate on our possible solutions until we feel like we've got something that works well enough. Even informal usability testing can reveal places where users are confused or make mistakes or take too many steps to get something done. The simplest approach is just to watch people try to use your product or a prototype of it. But if you're really serious about usability, you can do formal usability testing. Many years ago, I participated in a usability study at an IBM usability testing lab. I was working for Kodak in Rochester, New York, and I'm not quite sure how this came about, but IBM invited me to fly down to their usability lab in Texas. And I spent a few hours there in the lab going through the next version of their office automation system. I was familiar with the previous version, and it was pretty cool, really. I had cameras on my hands and on my face and on my screen and a microphone on. And so my job was to go through a bunch of scripts that they gave me of tasks to perform and to free associate what I was observing and what I was thinking as I tried to carry out these tasks. So it was really kind of interesting and hopefully useful to the people carrying out the usability test. Finally, every organization should learn from its previous experiences so it can do the next job even better. Project retrospectives and collecting and analyzing customer feedback are good ways to continuously improve your designs. So I've whizzed through a lot of examples here of both design principles and design lessons, using a lot of different kinds of products to illustrate them and kind of show how I learned these. But if you take away nothing else from this presentation, please remember the first 3 lessons I showed. Focus design on usage, not on product features. Design demands iteration, and whenever possible, try to involve real users. These 3 lessons alone can help you avoid creating thoughtlessly designed products. So thanks for joining us tonight. I hope you got some information that you can use from this presentation.